We are in our chapter 5, where we are trying to see some derivative properties in order to bypass the limit definition. Let's highlight what we have so far. I try and repeat this a good number of times because people are not always aware. They think about the big properties, the power rule, things like that, and they forget about the little ones, and then they make mistakes in those little properties. First, I have, well, there's no first. First in the list, I have the constant property, and today I'm going to phrase them using the big D notation. Derivative of a constant function is 0. Mix up the notation a little bit. Then we have, it doesn't really matter which order we do this. Let's say the constant times a function property. Doesn't really have a nicer name, but you get used to it. Constant times a function property that tells me that if I'm taking the derivative of, I'm going to call it this, some number times the essence of the function, the number can stay in front, and I'm just going to look at the derivative of the x portion, let's say. I call it the essence of the function. Then I have the sum difference property. Crucial to isolate different terms. The derivative of two terms, two functions added or subtracted is simply the derivative of each one added or subtracted, depending which one was done originally. So those are the properties that I very easily forget to give enough attention to because I'm so focused on the important ones like the power rule, where if I have, the power rule only says what it says. If I have a basic power of x, then the number goes in front, the new power of x is 1 less. For any number n, of course not 0, I need to actually have a power of x. And if it's 0, then that reduces to 1, because anything to the power of 0 is 1. So for all actual cases, the power rule is powerful, but it needs the other properties to get me to just x to the power of something. All the other properties are necessary. They're the support properties. But without them, the power rule can't technically do everything on its own. And we have some problems in 5.2 that we can use this power rule in combination with the support properties. But really at this stage I am quite restricted. Yes, I can do a fair bit, but not everything. Not everything. There's some more properties here. Now I'm going to leave this page to add those properties and do our examples on a new page so we don't run out of space. So if we look at problem 5.3 and we just take number 1, for example, my function, let's just call it y, is 2x plus 3 times negative 3x plus 2. Now in this case, yes, if I FOIL this out, given the properties I have, I can still find the derivative of this. So let's do that. Let's say option 1, given my current list of properties to find the derivative, I kind of have to simplify first. So it's the first ones, negative 6x squared. The outside ones, plus 4x. The inside ones, negative 9x. The last ones, plus 6. I can simplify that a little bit further. Because I'm using this function in a future step, I want to clean it up. So I have a reason to simplify. Then simplification is very important. Now I can take the derivative. Now you can write this however you want. Being aware of the steps that I'm doing for today, we're going to still list every step and do one step at a time. And then after today, we can relax that a little bit. Because I want to just be ready for the midterm question, potentially asking me to say every property as I'm doing it. I want to have a solid base to build on. So let me just write down, this is the derivative we're looking to find. Now I know for many of you, if someone has a chance, could you please close the door? People outside are so noisy. For many of you, it feels like torture to be that detailed in finding this derivative. I totally understand. And we're not going to do it for very long, only today. So I have to break up the terms and find the derivative of each term next or first, and I've used the sum difference property to do that. I can't forget those support properties and when I'm using them. I've seen people make mistakes because they neglect those little properties. They're not aware of what they're doing. As soon as I'm not aware of what I'm doing, mistakes are going to happen. Now, I can say I'll put the negative 6 in front. Then I need to take the derivative of the x squared still later. I'll put the 5 in front. And I still need to take the derivative of x. And I'll leave this for now. One property at a time, so I've only used the constant times a function property. If I now say negative 6, I don't want to simplify while doing this, though you're of course welcome to do that. 2 times x to the 1, we don't write the 1, minus 5 plus 0. I'll say 5, I'll say something in a second. Which properties have I used? If I now ask you, I'm doing this derivative for you. That's pretty much done. Right alongside it, all the properties that I've used to get to that last line. Which properties have I used? Have I used any properties? I've used the power rule. Which term did I use the power rule on? This first one. Yeah. This one. Let's number it like this. 1, power rule there. What did I do to go from the middle term to just minus 5? Which property did I use? It was the power rule again. Can everyone see that the power rule was used there? Because it was a power of x, x to the 1. The 1 goes in front, x to the 0, which is just 1. So it was the power rule again, 2, for the first and second term. and the property to get that 0. Let's call this number 3. 3. What property is that? The constant property. Now I do, admittedly, think of the derivative of x being 1 as sort of a separate property because it's so simple, it's so special. The slope of y equal x has a slope 1. The m in front of the x is 1. But technically it is the power rule. It is the power of x. Just x to the 1. All right. And then I can clean this up. Just maybe I want to. Negative 12x minus 5. Though you don't have to. You can leave the 0 there. I remember so well. When I was in high school, we had to leave our books open to show our work, and the teacher would walk around checking that we did our homework. And it was simplification things. And I left my plus 0 there because something simplified to 0. And he freaked out. Why do you leave the 0 there? It shouldn't be there. Why does it matter? More detail is better. It doesn't ruin your life being there. It's fine. No, he was not happy. So this is one option. Yes.
So what did you keep in the third one, the constant property one, the derivative of 6?
The constant property simply says if I'm taking the derivative of a number, whatever that number is, it's 0. Because whatever that number is, it's a horizontal line at some position. It's always horizontal, so it's always slope 0. Doesn't matter what the actual number is. It could be 1,000. It could be anything. As long as there are no x's in it. And that one is just a 6. But the issue with this function, sure, we could do it now. But if we had something more complicated that I may not want to necessarily FOIL out, or maybe I can't really FOIL it out, it would be nice to see this function's pieces as the first bracket and the second bracket and then being multiplied together. That would be nice. Because in some cases, I might not have these simple looking brackets, and FOILing it out is not necessarily an option. So, by way of the limit definition, one would have to prove that there is such a property, and it's called the product rule. And what it allows me to do is look at the pieces being multiplied together. Just like those two brackets. But it gives me a way around the simplification because we'll add more basic functions in a little while, and those don't simplify very nicely with other things. And there will come points where I have to have a property like this. Okay. Now I'm going to use the prime notation just because it looks a little nicer and easier to remember. It is the derivative of the first times the second plus the first times the derivative of the second. There's some symmetry there. It's not hard to remember. Why is it like that? Well, if you take Math 100, then we prove all these things by way of the limit definition. But that's more of a side note. If you're really curious, I'm happy to do it. But I don't want to let that distract me here. We are just concerned with using it. And of course, in order to use it, I have to remember exactly what it says. Some books swap them around, but I like the derivative of the first times the second, plus then swapped around first only derivative of the second. So let's see how that would work in our example and what we would get if we did that instead of simplifying first. Do I have this space? You know, I think I do. So, same example, option 2. Where am I? What was the function? So now, y equals, same thing, 2x plus 3, negative 3x plus 2. Now I'm going to see this as the first one and this as the second one being multiplied together. So the way I remember the product rule, I don't remember the f and the g. I think of it as a first and a second. Derivative of the first times the second plus the first times the derivative of the second. Or however you want to memorize it. Don't be too attached to the names that you use. So, the derivative. Well, I need to find the derivative of this. I'm just copying it down for no reason whatsoever. Habit. Sorry, this 3 doesn't look very good. All right. So, product rule says I take the derivative of the first, and I'll do that later, one property at a time, times the second just as it is, plus the first just as it is, times the derivative of the second. That is the product rule. Now you've just seen it. It might take a while to memorize, but you have to be very comfortable in what the product rule says so that you can apply it correctly. There are different ways to memorize it. You pick whatever works for you. Any questions on the application of the product rule? The rest now is just previous simpler properties and simplifying. Okay. Now I have to let's do this derivative in one go and simplify it at the same time. What do I get? Two. And then the negative 3x plus 2 doesn't move. Nothing happens to it. Just like this 2x plus 3, nothing happens to it. And then this, no, let me make a bracket here. This derivative, negative 3. Like that? You don't see my dot? No! Make it clear. It's multiplication. Otherwise, I don't know which way I'm going to go. I can just mark what I see and make it clear this is being multiplied. Which properties have I used for these derivatives? I've used many. Name one. I've used the power rule, absolutely. I've used the constant times the function. I've used the sum property. Lots of things happen in there. And my goal, ideally, in the beginning is to be aware. Even if you go slower than you'd want to, be aware of what I'm doing as a precaution. Now, this doesn't look the same as the previous answer. We might need to simplify it to make sure it is the same. So the 2 going in there is negative 6x, then plus 4. Then I have a negative 3 into the bracket there to give me a negative 6x again, and a negative 9. And I do get the same answer. Now, that's not a proof that the product rule works. It just helps verify it. Right now, you have options. You can look at, so it's a very good idea to look at your function. How am I going to proceed? Because now, with more properties, I have more options. And there isn't just one way to do it. If I look at this function, I decide which way, how do I want to proceed? Which way do I want to go? Do I want to simplify it first? Or do I want to see it as a product of two functions? Neither one of them's wrong or better than the other one. Just know your options. Questions on the product rule? Does it make sense? How to use it? No, it doesn't make sense? A little bit of sense? It's our first example. We obviously have to do more examples. So let us do that. And I'm going to do the properties, the more familiar properties, a little bit faster. But when I do the product rule, I want to just do the product rule. Let's do number 5, which is 1 plus root t times 2t squared minus 3. We're always seeing the x. Let's mix it up with a t. So now you can choose. Do I want to simplify that and then go to the derivative? Or do I want to see it as a product? Now we've done the early properties already, so let's practice the product rule in this case. So, whoopsie. I want to use the product rule, so I see a first and a second. So it's going to be the derivative of the first. Now make it clear that if you're using the big D notation, the variable has to be the appropriate variable. So it's a t in this case. Derivative of the first times the second plus the first times the derivative of the second. And because we've done a fair number of examples where we listed the properties, I assume you will practice that enough. We don't have to do it every single time as we get more comfortable. But I like the just laying out the product rule and then seeing what do I have to do. Many people try and do everything at once because they think it's more impressive if they can write as little as possible, everything in one line. It's totally up to you. I don't want to make a silly mistake. And it doesn't take much effort to now continue and finish these two simpler derivatives. The derivative, the first one here, now you can just look at the square root as it is, or you can see it as t to the 1/2, and then directly use the power rule as 1/2 t to the negative 1/2, and that bracket stays exactly as it is. This bracket as well. And then here, if you get more comfortable, you can totally say, well, the 2 goes in front and is going to be multiplied with this existing 2, giving me 4t. Totally fine. But let it happen naturally. Let it happen sort of automatically. When you're that comfortable and it's obvious what's happening, then simplify little things on the way. Don't force yourself to write less when you're not ready. And there's my answer. Do I simplify that further? You can, I'm not going to. There's no follow-up question. There's nothing more to do with that answer. Why would I waste my time? I have the simplification skills. It doesn't mean I have to do it all the time. There's a saying that a gentleman is someone who knows how to play the bagpipes, but chooses not to. Because I can simplify. Doesn't mean I have to do it every chance I get. But you're welcome to if you enjoy the process. Go right ahead. So, let us see something else. Oh, let's do a 6 before we move on. There, my function is, did I say 6? Yeah, sure. 2x plus 3 times 3x minus 4 times x plus 1. Do I have options? Yes, I have options. I could FOIL all of that out. But with that, maybe that has a little bit of a risk as well, where I could make a little mistake. Let's suppose we want to use the product rule on this. In fact, the midterm question might say, use the product rule. Then you don't have a choice. I have three things. Now, yes, this product rule could be expanded to three things. No, I don't want to do that. All I'll do is group two of them and see them as one thing times another thing. Only two at a time. Then the derivative is, by way of the product rule, the derivative of the first, whatever I chose to be the first. It doesn't have to be a single bracket or anything, just a first and a second, times the second, plus the first times the derivative of the second. That's still the product rule. For simplicity, I'm going to always just see two things at a time. There's no need to have a product rule and then a three-part product rule. And no, there's no need. This is going to be totally fine. I just have to know what to do. You could have seen the last two as one and then the first bracket as a single one. It's going to end up being the same thing. So you just make a choice. Then this derivative is again a product rule because there's the product of two things. So it's the derivative of the first times the second. And I don't want to do it all in one go, though you could if you're more comfortable with it. Plus the first times the derivative of the second between those two. I still have my x plus 1, and I still have this second portion that I'll put over here, 2x plus 3. It does get a little messy, yes, it's okay. It's not messy, it's just long. So I'm still breaking it up into steps instead of doing too much at once so that you can follow what we're doing. But the amount of detail that you show eventually is totally up to you. Is everyone happy with what I've done there? Or do you maybe feel something weird over here because you skipped breakfast maybe? Something's not right. Give me a second. You can say first, but let's have people look and think for themselves first. Because if you say it, they're just going to go with whatever you say. Everyone needs to think for themselves. Because in the midterm, there's no one else. Okay, everyone else is there, but no one else can help you. It's you on your own. Think for yourself. Is that correct or not? Do you still want to say something?
I was just going to ask, shouldn't you multiply x plus 1 to go?
The x plus 1 is multiplied to that whole first derivative. If this derivative turns out to be a whole thing, this x plus 1 still needs to be multiplied with all of it. And it's very easy to get caught up in one thing and then forget how to piece it all together again. Common mistakes that I see often, I try and mention so that you can be aware and avoid it. Now we're not quite done, are we? These little derivatives still need to be done. There's one, there's one, there's one. But they're not very complicated. This one is a 2, and then I copy everything else, making sure to copy correctly. And that middle derivative we still have to do is a 3, remembering that all of that needs to be multiplied with an x plus 1. And then I can't squeeze it in. 2x plus 3 gets copied, 3x minus 4 gets copied, times what? Sorry, maybe that wasn't clear of this question. Times what? Not 0. Some of it's 0. The derivative of x is 1. And the derivative of 1 is 0, so we don't like the 0. Feel free, if you have the need, you feel the urge to simplify, go right ahead. I will see you in about 5 minutes. I am not going to spend my time inefficiently. Any questions on how we got to that answer?
Do you have to combine the two, or can you somehow do it with all three? Or do
You could, but I'm not going to. The only product, I want to remember as little as possible, if I can get away with it. So the product rule only says what to do with two things multiplied together. And if that's the only product rule I'm going to remember, which it is, I have to somehow see it in an appropriate way. I'm not going to show anything else. There's no benefit. It does more harm than good trying to memorize a long, messy thing. It's not effective. Yes?
what happened in the third line?
What happened in the third line?
Yeah.
Just the
I
general.
got lost.
Can you be a little more specific? The first part, the second
first
part?
Because I thought it had to be
The first part we still had to resolve this derivative in the box.
Okay.
But that again is a product of two things. So I apply the product rule to that, which then becomes this. So it's a product rule inside a product rule. Yeah. Because why not? And that creates a little bit of a messy look, having to keep track of everything a little bit more carefully. It doesn't happen often. I'm just sort of emphasizing that the product rule as we remember it is sufficient, even though it could be a little messy. So if we look at these properties, we can handle a lot of things. In terms of functions being made up of pieces combined. We can handle numbers around the essence of the function. We can handle two pieces added or subtracted. We can handle two pieces multiplied. What's missing? Addition, subtraction, multiplication. We haven't done any sort of division. And we know from rational functions that that could be a thing. So, I have lots of space, wow. If I look, for example, at problem, I think we've done one. I've made one up. Let me backtrack a second. I can't remember exactly the example we did, but if I look, for example, at x squared minus 3x plus 1 over root x. Something like that, I can't remember. That is the ugliest square root I've ever seen. I can handle that. I just have to simplify. So that's okay. I can do that with my existing properties. But there are many, problem 5.4, I'll pick a random one. Let's go with 3. Let's not go with 3, let's go with 4. Where the denominator is more complicated in terms of having multiple terms, then it's less okay. I need more. I need a property. I can't simplify that and get to a point where my current list of properties will do the job. Can't do it. I can't get rid of that fraction aspect. I need a property to tell me how to handle fractions or fraction-like functions. It is the quotient rule. Now you're not going to like it. It's not going to make sense. But you do it by plugging this into the limit definition, and then a good number of minutes later, this pops out. It is another fraction, and the length of this line does not make me feel good. The top is very similar to the product rule in terms of appearance. Derivative of the top, numerator, times the denominator, bottom, but it's a minus, and then swapped around. So it's not that bad to remember because it has a very similar look. The bottom is the original denominator squared. Why? Well, that's what the limit definition says when I clean everything up in there. And I'm happy to show you. Just make sure we have like 15 to 20 minutes. It gets a little messy, but it comes out after cleanup to look like that. So yeah, it's not my favorite property, but everyone has to go through and memorize it. You can as well. It has a similar look, at least in part, to the product rule, which helps. So now if I use that on this function, let's see what that looks like. And I'll write out as much detail as I can. I have a top and a bottom. It says the derivative of the top times the bottom minus the top times the derivative of the bottom, which I still need to find, that's okay. And, oh man, ugly square root. And the new denominator is the original denominator squared. In this case, unfortunately, understanding where that formula comes from doesn't really help you memorize it in any way. It helps me sleep better at night, but it doesn't help me memorize. So I need to just know how to use it. And a question could say, specifically, use the quotient rule on this. Even in some cases, like the first one there, I do have a choice. I do have a choice. Many times, I don't have a choice. Is everyone happy with this setup? Even if in the beginning you flip back and forth and check all the pieces need to go in the right position, that's okay. Now, I don't have a lot to do, just a couple of simple derivatives. I'm not going to FOIL out and simplify the bottom. No one cares. Derivative of x is 1. You don't even have to write the 1 there, though I do like writing the 1, to remind myself that I did resolve that and figure out that derivative. It just happened to not be very significant. And then x. And then, what is that second top derivative? Most people, I'll show this first. Some people do memorize that and just write 1 over 2 root x. Perfectly fine. Most people, however, want to minimize what they memorize and then see this as a special case of the power rule and just apply the power rule. Especially because I don't have to simplify this. I don't care if it has a negative exponent and stuff. It doesn't look as clean as 1 over 2 root x. Who cares if I'm not simplifying it? No one cares. So you can go either way, doesn't matter to me. But whatever version you have has to be correct. So with the quotient rule, we're able to handle a lot of ways to make new functions. And you see that it's not the quotient rule in isolation. The other properties are still in there. I use the quotient rule here. But in the following line, we used a lot of properties. We definitely used the power rule for this derivative, as well as part of that one. To find this derivative over here, what other properties did I use? Did I use other properties? What are they? Constant property for sure. I also had to resolve this plus, and that's the sum property. So a friendly warning, yes, we don't write it every time. It becomes a little time consuming and tedious, but be aware of everything that's happening from one line to the next. I guess we have time for another one, why not? Any questions on this one? Not too bad. Let's see how bad it can get. Then any question you come across is going to be easier than this. And we have the time, why not? All right. I'm looking at problem 5.5. I'm looking at number 10. And with this, we are finished with chapter 5. We have this function over here. I do have a little check and see, can I get around the quotient rule? Because it's the biggest one to memorize with the most parts to it. And I could make little mistakes. If I can get around the quotient rule, I might take that. But if the denominator has multiple terms, there's no way around it. No real way. So I'm just going to go ahead, bite the bullet, and do it. As long as I take my time and let my patience scale with the complexity of the function. I know the bottom is going to be the bottom squared. Now I have to do the derivative of the top, and I'll do that in a second because I see the top has some more to it, times the bottom minus the top times the derivative of the bottom. Yes, that's not a super hard derivative. I'll do it in a second. That was just the quotient rule. Just the quotient rule. Just check. Are we done with this chapter? There's some more variety in the problems following, but it's still the same thing. Yeah. Chapter 5 done. Easy. Wow. Well, not easy, but it didn't take that long. If you are not sure about anything that we did, any property at any stage, you need to speak up because we're going to be doing these properties for the rest of the course. Everything's built on this. Any questions so far? Does this make sense? All right. Now, I do need to make this line. That's not going to be long enough, but that's okay. Copy down my denominator. Then, this first derivative that I still have to figure out is now a product rule. I could FOIL it out. I want to practice the product rule. So it's the derivative of the first. Let me write this out so I don't do too much at once. So of course you could do it right away as 2x. Derivative of the first times the second plus the first times the derivative of the second. All of that times 3x plus 2. I'm clearly out of space. I'm going to have to do it over here. The second term, x squared plus 1, x squared minus 2 stays. And I might as well do the derivative there, 3. Now finishing up those last two little derivatives should not be a problem. I'm going to write it out so I don't show you bad habits. This first one is just 2x, and that gets multiplied with x squared minus 2. Then I have my x squared plus 1 times 2x. Again, all of that multiplied with 3x plus 2. Then the bottom section is already done. I'm just copying it down. All over 3x plus 2 squared. Easy! Well, if you look at any individual thing that we did, it's just an application of the derivative property. It's just keeping track of brackets and everything and what goes where. So just go slower when the function needs you to go slower. That's all. So you can practice other questions in chapter 5, but make sure you can use any one of those properties. This was just a little tedious, sort of the worst case in terms of things happening. If I see the worst case, then anything else isn't that bad.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos.